I guess we can get started, right?
Yeah. All right. So welcome to the first planning meeting for cobrapy. My name is Henning Eriksen, and we're sending live here from the Center for Biosustainability in Copenhagen. And yeah, just to introduce myself, I just joined cobrapy as a researcher, and be happy to be the maintainer of cobrapy for the moment. And yeah, for this meeting, we planned 1 hour, and since we are several participants and have a lot to talk about, I would just like to ask every one of you to write your name in either the computer chat or to wave your hand or something so that we can keep a tab of the speaker list. And the agenda, as you see, is that we should first have a short brief usages of cobrapy around the world. So anyone who wants to share on that is very welcome to show. We'd like to hear what you're using it for, if you're developing features for other users and so on. And then we're gonna just get a small introduction to Cameo and the future of the relationship between Cameo and cobrapy as we would like to propose it, followed by a short discussion on scope and a longer discussion, which I guess is going to get a bit mixed up in between the two on the backlog that we collaboratively put together and discuss what to do with cobrapy and how to move on. So perhaps just to start, maybe you could say something on the use of cobrapy here. Considering where the yeah, exactly. No, that's what I was intending to write here. As a means of the description of what we use, and say something about what we're using cobrapy for.
Well, okay, so I mean, I started using cobrapy as the package that I was developing Cameo on top of, which is a biotechnology cell technology engineering package. So it implements a lot of brain learning methods that we published in the site. And along the way, we also developed this separate solver interface and a few other features that I'm going to cover in a couple of minutes that make cobrapy more efficient. And with me is also one of the PhD students at the Institute, Christian, who's actually developed a lot of the features in the package. And also actually a user PhD student that is actually developing, he's actually reconstructing a model also for biotech purposes. So I guess that's us, and maybe the next person which is left to our side is, I guess, Peter St. John. So maybe you can give a short intro.
Yeah, hey, thanks guys. So I'm Peter St. John. I'm working at the National Renewable Energy Lab in Golden, Colorado. My work is mainly in sort of building small models of metabolism to try to improve product yields for different fermentation products. So one of the things we're looking at is succinate and mucinate from different small microbes. Yeah, I've been doing that for about just over a year now. And yeah, that's my background's in sort of computational biology, gene regulation, and just sort of within the past year I've gotten into metabolic modeling. Great, yeah, do we want to move to the next guy?
Thank you very much.
Yeah, hi, my name is Matthias, Matthias König. I'm from the Humboldt University Berlin. I'm mainly worked on small kinetic models and a bit on network reconstruction, mainly of liver metabolism, and going now more into coupled models, hybrid models, and so on. And yeah, I'm really interested in cobrapy, and yeah, hope to learn more and hope to contribute more in the future.
Cool. Actually, I think we skipped Mike and Lena from Mayo Clinic, so maybe you wanna go next.
Go ahead. Yeah, okay, so I'm Lena. I'm a postdoc at the Mayo Clinic in the Center for Individualized Medicine, the microbiome program. I'm a microbial ecologist, so my interest is in using cobrapy to explore the dynamics of microbial communities based on the metabolism of each species. And these microbial communities are the ones, the project we're working right now is the gut microbiome, but it's hopefully we'll be able to extend it to other microbiomes in the human body.
And I'm Mike. I'm working in information technology, but I spend most of my time supporting the microbiome program here at the Center for Individualized Medicine. So Lena's the biologist, I'm the computer scientist, so I've been working on a lot of the tooling back behind all the metabolic modeling that we're doing. So we're interested in extending cobrapy, adding some additional features to it, and integrating it in with some of the other work that we've done to kind of get a more complete package.
Okay, thanks. Maybe Joao, you can like quickly say something.
Okay, hi. I'm João. I'm also a PhD student at CFP, although I'm not standing today with them. I think I've been developing the heuristic optimization stuff in Cameo as well as other features. And that's it. I think it's enough for now.
Thanks. And Hector is also with us.
Yeah, I managed to get in. Hi, I'm Hector Garcia. I work at the Joint Bioenergy Institute in Berkeley National Lab, and we work on quantitative metabolic modeling and frequency metabolic flux analysis.
And at last, Christian, I guess, and that's it.
Yeah, hi, my name is Christian. I'm working at the National Institute for Molecular Genetics here in Mexico, and we are mostly working with whole genome models of cancer tissues, and I'm now foraying also in microbiome, or microbial community modeling, mostly in diabetes.
Right. I mean, I hope like there seems to be some confusion with the time zone. So I think actually I have a couple of people who wanted to join, like Zach from UCSD, but maybe you can watch the YouTube stream afterwards. But I don't know. Anyways, like I guess next on the agenda is like my little part on like what I think.
Yeah, the time zones can't be helped. We'll have to redo this in another case in that sense.
Yeah.
So yeah, if we could then move on to a small presentation on cobrapy.
So I mean, this is just like very quickly how I see. I mean, we basically took over cobrapy, I guess, as the main maintainers, and I wanted to give a brief overview of what I think will probably happen, mainly because I want to get feedback if you see any red flags with our plans, and if this would actually ruin your life with working with cobrapy, because that's definitely something that we want to avoid. So maybe just quickly, if you compare Cameo versus cobrapy, I mean, there are also other things, but maybe the most important things is that I developed a separate solver interface for a Cameo that uses symbolic math by using SymPy, which is a symbolic math package in Python. So you can actually write, I mean, if you're familiar with GAMS, for example, it's a fairly similar concept in the way that you can just formulate the optimization problems using symbolic math. And I mean, we have two fairly stable interfaces. One is for GLPK, and the other one is for CPLEX. There's one for Gurobi that is kind of almost passing all the unit tests, and they're like more longer-term plans to even extend the solver interface to also like nonlinear problems and so on, like maybe having a GAMS interface and so on. But the most important part for like why I did this in Cameo was that I was not satisfied with the amount of overhead that is associated with like writing out the problem structure every time you run a simulation, and also like that cobrapy would basically not take advantage of a previously found solution, which affects methods like flux variability analysis, for example, but also if you determine like essential genes or reactions. So the basic concept is, like in Cameo, is the solver interface is always attached to the model structure. So if you do a modification by either removing or adding a reaction, it will always be like updated in the solver instantaneously. And the solver basically allows to reuse a previously found solution. It will always do that. And I mean, that's like one advantage, that it's more efficient. But on the other hand, it's also like being able to write complicated optimization problems using symbolic math is very convenient if you have to, for example, transcribe an algorithm that has been published. Because people usually would not like write the matrix formulas they used for like defining the problem, but they would just write a system of equations, and then it's up to you to determine how to best get this done in your solver. So, and another thing that we do is that, because making copies of cobrapy models is very expensive, is that we develop like this kind of command line design pattern where you have like, you basically store operations as objects, and then these can have also like undo operations. So, but we also take advantage of like using context managers to make this an elegant syntax in the way that you can just create such a time machine object, and then you can pass it to a couple of methods that are like that are modifying the model structure, and these methods will be able will know what needs to be done in order to reverse whatever has been changed. So the way the context manager works is like, if you exit the with scope, then basically everything will be rolled back, and that's very convenient if you do knockouts or you change an objective or you change bounds and so on and so on, which is if you would have to do this all by hand, like the rewinding, it would become very verbose. And it's also super fast because it avoids making copies. So maybe I can just, yeah, can you go to the next slide? Yes, so the way I see how cobrapy will be eventually refactored is that we will move, so in Cameo there's a solver-based model class that inherits from cobrapy's model, and move all these solver interface specific things into cobrapy, into the cobrapy model. And I actually already did this in an experimental branch, and most unit tests actually pass. I also started doing a few benchmarks to see how this affects like performance of cobrapy methods. So what I see is that, but that's not very surprising, is since we do things incrementally, is that if you like operations that would add new constraints by, for example, adding new reactions, are slower than cobrapy, maybe on the order of like 10 times slower. But so that's like one drawback. And the other issues that I see is that if people actually develop in the wild and have not actually published packages that use the current cobrapy solver interfaces, then I mean, we would not like immediately remove those solver interfaces and break everything, but eventually we will probably deprecate the old solver interfaces. Maybe coming back to the issue that things are slower, I don't see this as an issue, because it's not the bottleneck when you do analysis, when you perform analysis with these models, because usually you load a model and then you perform a simulation, or you do smaller modification, you change bounds and things like that. So it's rarely the case that you would add 10,000 reactions, remove 10,000 reactions, add 10,000 reactions, and so on and so on. So, but maybe you have a different view, and we can discuss this in a second. Just to briefly mention, we also have developed a lot of other things, I think, that are not strain design related. One of them is, for example, that we've built like we included in the package a way to access like models from databases that provide APIs. For example, the big database API, you can just directly get access to a model in this database without actually having to download a file and so on. Next slide. So I actually have this experimental branch. It looks like refactoring this, what I just presented on the previous slide, would not be much work, maybe like 2-3 weeks. And also, I think it's already apparent that we need to do this actually very soon. Otherwise, it's kind of awkward for people to still like maybe contribute or develop things on top of the old solver interfaces, while we already have plans to probably like deprecate those in the future. Maybe the last slide. So I guess the plan that I have for this is, given that this experimental branch was not so hard to set up and most unit tests run, we would probably like merge these things back from Cameo into cobrapy, like making sure that no things break in the unit test suite. And then we would, over the next couple of months, maybe add solver interfaces. And that's a very difficult question, is what solver faces, which solvers are actually used besides Cplex, cobrapy, and GLPK. Maybe everyone like here in the group can maybe later state what exactly they're using and if there's anything else that we are missing currently. So the idea would be, if we're actually missing something that is urgently needed, then we would include this into this opt-lang solver interface that I've written before. And if you're happy with this, we would then deprecate those solver interfaces, but by just raising messages informing everyone that these solver interfaces might be gone in the future. And then other things would happen, and that's also a big, I think, advantage in Cameo currently, that we have a lot more basic simulation methods than cobrapy has. For example, there's no linear MoMA implementation in cobrapy currently. So I think cobrapy's like basic simulation methods repertoire would also benefit a lot from this, because we can just like move all these generic constraint-based modeling methods back into cobrapy, because they're not strain design related. Yes, that's basically what my view on what we would like to do in the short term in terms of like adding features back, like merging features back from Cameo into cobrapy. So that's all I wanted to say about this. So.
Thanks. Any reactions to that? Comments, questions?
Yeah, I have a comment. I think the time machine class is definitely cool, but I guess, you know, I'd want to think a bit more about how that would work in terms of, you know, the different workflows you'd have with making these models. And do you guys sort of have examples of how that works? You know, one thing that I'd like to see is sort of context managers that deal with, you know, the media for a model. So for instance, you know, whether or not you're growing on glucose or xylose or some other bounds, whether or not it's aerobic, anaerobic, and just sort of being able to really easily add and remove different media in sort of a intuitive manner, I think would be really important to add. And I think one of the things that goes along with that is, you know, being able to pick out reactions at the boundary and then being able to set their bounds appropriately fairly quickly. I don't know if that's handled by the time machine or if there's other things that we have to think about there.
Maybe we can quickly see, like, for example, a reaction has, but that's actually a cobrapy method that we extended, a change underscore bounds method. At least I'm not, sometimes I get confused about the APIs of both packages, but I think it has. And this basically, we just added another keyword argument, which is called time underscore machine. And there you can just give it a time machine. So if you then change the bounds and you exit the width scope, then basically it gets rolled back. So, I mean, that's, and we did this like for almost all modifying methods that the model class has. And I guess good examples of how we use it is if you look at the different methods that we implemented, I mean, we basically use it everywhere in order to avoid copies. So regarding media, I totally agree that like cobrapy and neither Cameo has a good way of like defining media and setting media. I mean, we have something, but it's not very satisfying. I mean, at least we have something if you do model.media, and that's not part of cobrapy. It will give you all the exchange reactions where things can enter the cell. But it's not something that is defined by the user. It's just determined from the bounds that are set on exchanges.
Yeah, the other, I think, concern is that I think that cobrapy is trying to maintain compatibility with the SBML standard, because there is a media option in SBML, and some models come with media preloaded. So if you do model.media there, I think it's trying to load up media from the SBML. So I'm not sure if we could overwrite that property and then make a... I didn't
even know that. But that's part of the FBC extension then, or?
I'm assuming. I don't really use it, but I know...
There's no media in SBML, definitely not. Also not in the FBC extension. There's nothing in there. But about the media definitions also, like I thought a bit in the same direction. It would be nice to have like some helper classes also, so to define simulations, or mainly like what things I would change on a model and to run a simulation. Like mainly put everything together, then I have the model and the simulation class, and then the simulation is performed in the fastest way, so that I somehow store all the changes and so on in a certain class.
Like a lot of things like that would benefit from what you just said. We implemented simulation methods using classes. So you would always you would initiate an object for a particular method, like opgene, for example, and then you would have a run method, and you can run it. But basically, since it's quite expensive to sometimes build all these special optimization problems for particular algorithms, it's important to not lose it, which is hard to do if you just have a functional interface, right? So, I mean, a lot of things are functional in cobrapy just because the MATLAB version was functional, obviously. So I think where things can be benefit speed-wise, we will probably do these things as well. I mean, the basic simulation methods that we have are also functional, but then we have a cache object that you can pass to it. That's kind of a different way of dealing with keeping state in order not to have to reinitialize everything from scratch every time. Okay, I don't know if that answers your question or if we...
By the way, regarding... Sorry.
Yes?
By the way, regarding the media issue, I think Chris Henry in KBS has been working on this already.
Which issue?
Chris Henry in the KBS has been working on containing a media object that can be changed and adapted for flux analysis. So that's something you may want to consider.
Well, Mike, can you comment on that since you have a direct connection to Chris Henry? And can you turn on your microphone?
Yeah, sorry. Yeah, I know, on the model seed side, they do have the concept of a media object, I guess. It's not really an object, but a way to keep track of what metabolites you have in a media. I'm not aware that he's been working at all on extending that into cobrapy itself. But, I mean, they certainly have the concept there that we could take and translate over.
I mean, it would, yeah, I mean, it would be nice to maybe learn from that, or maybe also be compatible with that. But I totally agree that dealing in a more sane way with media instead of just setting bounds would be nice. So maybe you can, I mean, that also, we also need to talk about what you think the scope of cobrapy should be in the long term. But I mean, personally, I would say having a good way to define media conditions is a very generic problem in constraint-based modeling. So I would say this needs to be solved in cobrapy and not in a separate package. So you're taking notes, right? So
yeah,
yes. So that's definitely noted. Maybe we can come up with good ideas, making pull requests, discuss of how a media should be defined or used or set. What do you think, Peter?
Yeah, I think that's a great idea. I think before we start writing code, we should probably, just come up with some examples of how these things might work. So I certainly use a lot of, I have a branch of it where I use the initialize growth media function that's already in cobrapy. And then I have a function that just sort of generates the same dictionaries. But I think using dictionaries in that sense makes a lot of sense. So yeah. Let's put some pull requests in with just some basic examples, and then go from there.
Yeah, maybe coming back to the solver interface issue, let's get a sample of people that attended. Did anyone write code based on the solver interface? I mean, in the sense that you really use the low-level API in order to manipulate the objects. The way, for example, Ali did it for flux variability analysis. Instead of operating on the model, which is how it should be done, and that's how it's done in Cameo. In order for a speed up effect, he would only operate on the solver object. So is that something that people have done? I mean,
yeah, I've written some stuff using Cobra's existing solver interface, mainly just because that's what's there, and I don't want to rewrite the whole thing. But I think I wrote one that was a linear MoMA when I didn't have a Cplex license. But it's not easy, and I think that swapping out the solver interface would make those sorts of changes a lot easier.
Okay, so it might break some stuff, but I mean, you would actually appreciate maybe having a more elegant solver interface eventually, or?
Yeah, I mean, anything that would break is already in the package, so you'd see it on unit tests.
Okay.
Yeah, we haven't been working on anything at that low of a level, so we don't have anything that would break.
Well,
right. Christian, you also had something to say on that?
Yeah, I have one package that actually heavily depends on it, which is like a reconstruction algorithm, which I ported from a MATLAB thing. And maybe, yeah, I just wanted to mention, because you said earlier that cobrapy doesn't recycle solutions, it actually does recycle previous solutions. Like the solution base is always kept in the object. But
yes, so, but it's kept on the solver object, right?
Yes.
You always have your methods in terms of the solver object, which is kind of awkward because, I mean, in the end, you would like to operate on the model. And I mean, that's at least how I see it. But I mean, if you do that, why not just operate on the solver object entirely? It's kind of, I mean, but that's also a design decision. But would you have strong feelings? I mean,
no, actually, I'm absolutely in favor of swapping out the solver interface for Optling, as I wrote it on Trello, because we have debugged a lot of problems with the solver interface in cobrapy. So the GLPK interface had a lot of small bugs, and so I think it would be cool to have that in its own package that actually gets tested and is a bit more isolated. So I'm actually in favor. Just like deprecating old solvers is also a really good idea, I think, because there's a lot of solvers that actually don't work anymore. So the coin interface that connects to CLP, for instance, has never been ported to Python 3, and I think that has been like this for years. It's not functional. And there's a lot of Java solvers I have never really understood.
Is anyone else?
Are doing that.
Is there anyone else that is using these old Java solvers?
Yes.
That makes it easy.
I mean, maybe just to give some context, I think the reason that cobrapy also has so many solver interfaces is that Ali was basically writing this response to this paper, the Mongoose paper, and he wanted to show us in as many solvers as possible that the paper is basically, no, it's not wrong, but it's like to show that in general you can actually solve constraint-based model using all kinds of solvers that are not exact. But I don't know if like this is, I mean, we need to like support this forever, because I doubt that many people use it. And it's kind of funny because the coin interface was something that I at least wasted 2 months of my life trying to make this work for my purposes. And at some point I was so fed up that I just decided I can like write my own solver interface. I'm not sure if this was a good decision, because now I have to maintain it for a time. But I mean, I just didn't see the point of actually having something that it should be a generic solver interface, because that's what the coin project did, but making it so hard to install that it's basically useless. So yes, that's basically what's the motivation of why we started doing this, right?
So my take-home message is that and please wave your hands if it's wrong, that we could switch to Optlang without breaking anything or disturbing anyone's current use patterns.
Just a quick question on why Optlang over other sort of Python-based solver interfaces. I know there's also CVXPy. There's a few other ones too. Just a quick question. Yeah, I don't know if you. I think you guys wrote Optlang. Is that correct?
Yes, and I mean, I'm not the person that usually just writes his own stuff. So I did my research, and the issue with these are actually all like really good solver interfaces, but they're not efficient because most of them actually rely on either using the command line interfaces. So they again would have the overhead of creating the problems every time you solve, and also not really taking advantage of previously found solutions. So I mean, there's CVXOpt and all these other things. They're really nice if you don't have to solve like millions of problems, right? So we have to, like, if you do heuristic optimization, you don't want to write the problem structure every time you solve your problem. That's kind of, that's not what we wanted. So we had to write something that is like as efficient as possible without having to do a lot of things on the user side. And maybe just to give an example, if you as a user just want to write a quick FEA, which is just you iterate over all the reactions, you make the reaction the objective and you optimize this. If you do this currently in cobrapy, I mean, it simply runs forever. Like that's not what I see as a good user experience. If you just come here and you want to implement a new method, and then by the way, no, you have to actually use the solver object now to make it speedy. I think it's just things should be working out of the box by using the general like high level API for manipulating models, and things should still run fast. That's what we want to change basically by refactoring cobrapy.
Cool, sounds good. Yeah, thank you for that.
That seems.
Perhaps I can comment. For me, it's like as faster as the switch is made, the better. Like I'm mainly just not writing anything against the Cobra interface because I'm waiting that it is switched, and I don't want to write in Cameo right now. So I'm mainly waiting until the switch is made, and everything which is like more performant and more simple is like totally supported from my side. And yeah.
Well, then I guess we should just go ahead and do it. And I mean, just like deprecate stuff, but keep it around maybe and see what people comment, right? And let's see. But I'm not as anxious. I mean, I'm not as afraid anymore after hearing like a couple of opinions now, because it looks in general like people will not really suffer from it. So, yeah.
In addition to the discussion on Oplang, one point that has arisen here that I start to feel is that we're entering the topic of the scope discussion. What is cobrapy, and what goes into cobrapy and what doesn't? And one way to look at it, as I start to see, is that cobrapy provides everything that is needed to define a model, to run basic analysis and sensitivity analysis, and to work with the model and solve it and so on. And media definitions and all of that. The question is, how about all the other things, and where do we say that we should move on or not? And so, is there someone that has any comment on that immediately? Because now we start to paint the picture of cobrapy bringing the basic infrastructure and other packages providing other features. Say.
Yeah, I think that makes a lot of sense. Sort of like the NumPy SciPy model for how the Python ecosystem is split. I think cobrapy should definitely be that kernel that everyone can use in common with other things on the side.
Yeah, I also agree with Peter, and think that basically to concentrate on the core that most of the users are actually using. So, for instance, we had the example of microbiome community modeling and stuff, and I think that would be cool for like a small part of users, but not all of them are using it. So I don't think that kind of stuff should be in there. And pretty much oriented on the Cobra toolbox or MATLAB. So I think flux sampling, for instance, could fit in there because it's a pretty basic operation. Maybe the basic visualization, as Peter has already shown, but everything else should actually build on top of it and be its own package. Otherwise, you will end up with a huge monolithic package which takes hours to install and stuff like that. So. Yeah.
Perhaps a comment. I did a lot in Cytoscape, and they have like it's a Java program, but they have a really nice plugin or app infrastructure. And perhaps it would be nice for cobrapy to really define the boundaries and then give like some tutorial documentation how to write a good cobrapy package, which nicely integrates with the core and which is tested good and so on. And so that you build this core, but like provide a way for others to link packages to it.
I think that sounds like. Sorry, please.
Go ahead. I guess our concern there was just that as you add these apps or plugins, that there is a way to find them and that people know that they're available, right? Because I agree that you potentially end up with a big monolithic package, but going the other way, you also potentially end up in a situation where somebody's made a nice package that would really help you out, but you can't find it, and you end up having to duplicate what somebody has already done.
So we were discussing this morning, and I mean, we thought about like one scenario could be you basically revamp the Open Cobra website as certain institution specific. Just make it like a generic, like this is a open source community website, and basically using this as a platform for hosting all different kinds of packages that are used. And maybe going even one step further, like if people maybe would develop packages outside of the Open Cobra GitHub organization, I think in principle, I mean, every project that is like based on cobrapy and I mean, we deem like is a useful package, and like, I mean, it also remains to be defined of like I guess what Matthias said, like in terms of defining like tutorials on how to write a package that is like would be considered to be a good extension to cobrapy. So everyone that would want to host their project on Open Cobra, the GitHub organization, that would be never an issue. But I guess people sometimes would like to keep the projects under their own organizations, and then I think we will have to find a solution of maybe we were thinking about just forking projects, but then it's hard to keep them in sync, and that's also not really the purpose of forks. But anyways, a solution to that can be found. But I guess the main website where people could basically search for extensions that could be useful could be this Open Cobra website. If everyone, I guess, agrees that this would be a good place. Otherwise, one could think about making a new website with a different name. But on the other hand, this has been around for quite some time, so I guess a lot of people are actually aware of it. So I guess I would be in favor to just like make the Open Cobra website much more open and host all different kinds of projects without making this like being owned by a particular institution or lab, right? So I mean, do you have any opinions? I mean, maybe especially Mike, since you, I mean, you develop basically a package for accessing model seed, and there's still a question of if we should include this maybe in in cobrapy because it's quite IO related, but on the other hand, maybe it could be a separate package. So if it would be a separate package, you think just hosting it on the Open Cobra website, that would be a good place for making, I mean, advertising it and making people aware of it, or?
Yeah, and actually Len and I were talking basically exactly the model that you just laid out about yesterday. That makes sense to us to be able to put stuff out on the Open Cobra website or as another project inside of the organization on GitHub. Yeah, and I agree with you that having it not associated with a particular institution, but just for the whole community is the way to go.
Yes, so I mean, one could think about a model where either all institutions of all people that contributed are like in the footer of the page, but that might become ridiculous at some point. So I'd rather like make this just a, you know, this is a community website where things are hosted. Of course, I would have to double check that everyone like who initiated this website is like fine with it, but I would not anticipate any like particular strong opinions on that. But anyways, I cannot really like 100% say that this is going to happen, but that's definitely something that we would like to see happen, because I think that's a good way of making this much more open. And maybe also just because, I mean, we're also like mostly academics and we need to publish. I mean, in terms of cobrapy, I would also just, I mean, there's no particular reason to publish something right now, but maybe in 2 or 3 years from now, when like a lot of new things happen, or it would be worthy to like make a paper out of it, one would just like, it's so easy nowadays on GitHub to see like contributions. So I mean, everyone who like significantly contributed, you could basically just make like a community publication and just submit it together. So I think, I mean, I don't know what your opinions are on that, but I think that would be nice. So
another source of inspiration there could be Bioconductor, which is very successful community for our packages for computational biology, bioinformatics, where we have a submission process and a review, and all packages are continuous integration tested and so on. And
yeah, AstroPy as well has a really nice sort of model for hosting a core package and then community packages. Another thing to look at.
Yeah.
Yeah, I guess we can in general just maybe do some research on like, maybe also the Jupyter project, I think is also really great. And you see also like kind of that a couple of different core developer teams have formed around different projects. So that would also, I mean, if you attract even more people, like that would be a nice way like to distribute different people to different things. But I guess it's a little early to discuss that, but to think about this, but that's how I would see it like maybe in 5 or 6 years from now. So great. Well, what else is on the agenda? I think
if we don't have any more comments on that, perhaps we could then together just look at the Trello board and help prioritizing the list. And after we've done that, then I will sort this into the GitHub projects and keep track of keep track of the thoughts and the ongoing progress on these topics. Does it sound right? Then
great.
So one thing that I'm immediately seeing, I put the labels here, is this swapping cobrapy solvers, since I would argue that this is really quite important to get done, as they say, in order for others to be able to contribute it with the new solver interface. Does that seem clear?
Yeah, I think that's fantastic. I also like the idea of, I mean, I would sort of prefer if you could specify the type of solver you want in model.optimize. I think that would go a long way in sort of condensing, you know, how you solve the models.
Yeah, I'm not quite, but that's also the details that we can discuss later, because I'm not, so currently you would change the solver in Cameo by, there's an attribute called solver, so model.solver, you can basically give it either an oplang interface, or you can use a string to specify the solver. So because if I guess I could see both ways, but that's something we can discuss later, I guess. Yes.
Yeah, it goes in the refactoring, and both of that anyway is quite high priority, since it's blocking many other activities, I would say. And then as we move on, good management of growth media, and is like, I mean, this also somehow comes in together with after the that's something that we can do after the refactoring. Shall we just do it like this, that I place them as they come along here, and then we say for the next one, does it go above or below the other one? So if we have elementary flux modes and minimum cut sets, does this belong in cobrapy?
So yeah, how do people feel about that? I have a Python interface right now that I've sort of separated from cobrapy that I use to calculate both of these two things. That could certainly be a separate package. But if people felt strongly about it, I could try to put in pull requests. The elementary flux modes does require Java, a specific version, Java 1.7. And the minimum cut sets is a compiled C extension. So yeah, how do you feel about that?
Yeah, that's a tricky one. We actually, so you actually, but one quick question, that doesn't depend on the old solver interfaces though? So I mean, the Java one is basically a wrapper for this Java tool that calculates EFMs, right?
Yeah, and then the C extension also doesn't rely on the solver. It's essentially a command line tool that I've wrapped in Python.
Yeah, I mean, we have, it's not completely tested yet, but I think it's almost done. We have a shortest elementary flux modes generator class, and that also comes with minimal cut sets. And we mainly did this because there's a strain design method that is based on that. I would say it's fairly basic. If it doesn't come with a lot of dependencies, I would put it probably in cobrapy.
Let's see, I can certainly share the code that I'm working on and sort of maybe post it on the GitHub page as a separate repo, and then you guys can look at it and see what you think. That might be the best way forward.
I think always when something comes with a new dependency, it would always be like tricky to decide if that is worth the effort to keep this in a core package. But we should just definitely take a look at this case. Maybe it can be fairly easily integrated without making cobrapy packaging a nightmare, because that's also like something to consider. Okay, so.
Well, that's great.
I think it's just from like a feature priority. I think it would be just great to have elementary flux modes and minimal cut sets. It's kind of like these communities have always been like kind of separate, but it's kind of silly because like they're not so far away from each other, and there are like many very good methods now that have recently been developed, especially for strain design, that are based on those. And they also give you kind of a different set of results. So I'm all in favor to like maybe just soften cobrapy a little bit, and also like taking up methods from slightly different fields that are very related though. So
sounds about right. Moving on after that, so this is then clearly something that should be in cobrapy. And moving on to the visualizations, really liking your D3 Flux tool. It's really cool. I really like that it works also if you don't have a map, as opposed to Azure, where you always have to have that map, and for smaller networks that can become a blockage for using it. So that's really nice. One point I would like to say, so I saw you made it into its own package, and there I wonder, like, well, how do you feel about that, Peter? have that as another package in
Yeah, I'm fine with it. I mean, honestly, this was a tool that I had made sort of for myself to make graphs. If other people think it's useful, I'm happy to share it. I think there are probably some issues with the package currently, but I can certainly keep working on the distribution of it. But I mean, this could be certainly one of the things that we host on OpenCobra's GitHub. I'm totally fine with it being a separate package.
Perfect. Flux sampling has been requested here from other our colleagues, and also nice to see that it's come up here.
Did anyone look recently at this OpGP sampler? I think, Christian, you said that it has not been maintained for a really long time, but I'm not sure what happened with it. So,
well, the OpGP sampler has two things. First, it's also a C binding, so it was a huge C code base, and it's only Python 2. And yeah, it has been published, and then nobody touched it afterwards. But actually, the algorithm is really simple. So, like making a pure Python version of that algorithm would be really very little code, I think, and that could work. I don't know how fast it would be, but I mean, we could just do it and see if it works for our purposes. And if it does, well, we can put it inside or into its own package, whatever you like.
I would like to add something. I think we discussed this. I mean, is this sampling stuff something that is more general than for models? It's more for the optimization itself. And maybe it should go into a lower level, maybe like in Optlang, or I don't know what's your opinion, but this is a problem that maybe helps other people, not only us when we work with models, but other people that work with optimization.
You mean making basically a generic sample convex basis package?
Yeah, something like that. Because it makes, I mean, probably there's something out there, maybe, I don't know, I didn't search for it, but if we make it too specific, like the OpGP sampler for models, then other people won't use it. And well, one of the, maybe it's better if we can make it generic and use it and maybe make another package inside of Optlang that we can then use to, and then we can include it in cobrapy somehow.
I mean, I guess we can probably just put in the backlog, and then if we find time, and anyone finds time to make this Python implementation based on the OpGP sampler code, and then see how it works. Maybe then refactor it in a way where it's either based, we have a generic subpackage and then like the biology on top. And anyways, I think having sampling, although I'm not like a big fan or user, I think there's a big need in the community to have sampling, and cobrapy doesn't currently have it very conveniently. While the MATLAB version has it, right? So, I see Zach joined. Hi, Zach, can you quickly say if you got confused by the time zone?
Yes.
Yes. You're very sorry.
I think it might have been my fault.
Since you joined as the last person here, probably yes. But it looks like Google gives a different answer than like other time zone websites. So I guess there seems to be some, I don't know, confusion about what Central European time is, which is kind of worrying. But
right. It's okay.
I mean, you can, since this is all recorded, and then you can maybe look or watch the live stream and let us know what will be discussed, because that would be valuable input.
Right, I will. But I'm here, if there were any questions that I can answer, I'm here to answer them. Otherwise, I'll just watch what you guys were already talking about.
Well, currently, we basically, I mean, we just discussed a lot of things about the solver interfaces, and I mean, I know that you are aware of these things, so I guess you actually didn't miss a lot. So currently, we're actually working through the Trello board and trying to see, I mean, what should probably happen, like in the short term. So
sure.
Yes.
Cool.
So then I would say that flux sampling, I mean, in a way, it doesn't matter so much. Like the priorities of these things isn't so relevant. Eventually, we will pick these things up, and whoever else would be willing to contribute is, of course, always willing to do so. But I guess the sorting of what we see fits very well in cobrapy and what fits better in another package is a good delineation to make here. FBA variants.
I mean, I know, Peter, that was like, you made this point, because you mentioned a couple of very exotic FBA methods I've never heard of. So I guess
Oh, I
for
don't.
anyone to
Yeah.
do that, it makes sense to wait until the solver interface refactoring has happened, because they should, I guess, be implemented using this new solver interface, right?
Either way, they're blocked, but are they something that we like to see in cobrapy, or would we rather see them in a different package?
I mean, Peter, can you maybe quickly explain?
Yeah, I think this was Christian's card. I don't.
I'm sorry. Okay, so it's Christian.
No problem.
Yeah, I mean, the basic idea was that right now in cobrapy, you're pretty much dependent that you have a biomass function. And
Yeah.
I mean, a lot of you guys, you work with bacteria and stuff. So, I mean, for you, that's a no problem. But if you work with human tissues, like, this stuff is usually almost impossible to get. So with a lot of cases, we really don't have a biomass function. And then a lot of the FBA versions of cobrapy don't work for you anymore. So I would love to see something that maybe is not so dependent on it. Like the inverse FBA, actually, I don't know. I mean, you need to have flux measurements to get it. It gives you the objective function. So, I mean, it's a cool feature, but most of the times we don't really have flux measurements.
But then surely it makes sense to have cobrapy that we can support the different use cases for FBA.
Yeah,
Well,
I think
it sounds like it's also kind of data-driven, right?
yes.
So I'm not sure. I think this whole thing of where methods are that kind of take omics data or any other kind of data, this sounds like this should be in separate packages. Maybe, I don't know, like, because it opens up like a whole other issue with like, how do you actually import data and things like that, to support different formats of data. And I mean, but I'm not sure like how
it ties into the 13C flux, so maybe we can bring that in too. I don't know if that helps answer the question or makes it more difficult.
Well, I mean, maybe Hector can quickly say something about, we had a meeting last week about the package that has been developed or has been developed at JBay, but that's more about like using C13 flux data in.
Yeah, I mean, what we did is using 13C labeling data to constrain fluxes, right? I mean, other omics data is not in the package.
Yes, but it's like
So,
one time. It's like you see, it's already kind of, it needs a whole package to like deal with this data in order to.
Absolutely. The 13C stuff takes much longer for doing any calculation and any tests. So I would put it somewhere else, separate from cobrapy.
Yeah.
Yeah, I also have something to. So we have this driven package that at CFP that already tackles some problems. For example, we have these different methods to include RNA-seq or even some amount of protein measurement. And there's a processing step in between. For example, I would say that you have to match these Boolean rules with the reactions and then map and that's a problem that's common to a set of methods. And we have a package that handles that and then runs different methods such as GIME or IMAT, and in the future other implementations. But it handles both things, handling the data and simulating the models in the specific context of handling the data.
So, okay, Christian, I guess you deal with a lot of human data then.
Yes, only human data, yeah.
Would you like to see then also methods in cobrapy itself that would deal with this data? Or, I mean, I just see, this is like, for me, it looks like this is like screams. This needs to be a package that is specific for dealing with like these intricacies that, for example, we microbial people don't have, right? So it's maybe in that sense not as generic as like.
I think we don't really need to implement all those methods. Like in the long run, I think the only thing that I think might be interesting for cobrapy is like not always like really depending on the biomass function, but actually allowing to constrain the model just by some metabolic essential functions. No? Like we use a lot, for instance, to say, okay, I want to work in redox balance. I want this list of metabolites to be producible by the model and stuff like that. And I think with the switching out with Opling, that could be resolved pretty easily, no? Because right now it's really ugly to do that in cobrapy because I have to create a lot of mock reactions, which kind of get mixed up with the real reactions, and then have to do some tricks to get all that stuff into the solver. So I would say we don't really have to implement all those methods, just make it easier to create like a mock metabolites and or mock variables and additional constraints, and to actually solve models with that. Because for parsimonious FBA, for instance, you do not necessarily need a biomass function. You could just put some constraints of certain fluxes or certain metabolic functions that have to be fulfilled, and then do the second parsimonious stuff on top of that. And I don't think we should implement all those algorithms because basically 2 of them get published every week or every month, no? So, but just make it a bit easier to implement them on top of cobrapy.
So how about we keep this card for going into the package, but later on perhaps rephrasing it into not actually implementing these here, but rather making the nuts and bolts in cobrapy easier for that. Is that a good interpretation of? Yeah, perfect.
I think there's, I mean, in general, there's a lot of opportunities now to also think about additional and more complex like constraints that you can put on top of the model, because it's just easier to like just add constraints.
Exactly. It should be as easy as possible to write arbitrary mathematical constraints independent of biology or so. So that you can just put your math in there and it is a constraint of the problem and that's it. And this should be very easy.
Solver side, in the long run, what I see is that people could even write nonlinear constraints and then they can solve it, right? Good luck doing this with matrix formalism and like whatever other, I don't know, like just having generic solver interfaces there. I don't know, but so that's where I would like to head. And also, I think that would already be like relevant to what Hector is doing, because there you actually solve to some extent nonlinear problems. So yeah, it's actually not that far off, right? So.
Yeah, 30C, it's all, you know, the main constraints are nonlinear. That's what makes it hard to solve, right?
Yeah. Okay.
Okay. So the next couple of cards I would like to treat as one where we have this tighter integration with querying out the database and also this like translation between ID types. And here we are actually working on microservices framework to handle some of these aspects, where one idea is, for example, like to be able to take a model and update all the identifiers in there to another set of identifiers that you use, for example, like go from whatever identifiers you have to UniProt identifiers for your proteins instead. And as that kind of effort already exists, to me, this looks really like great for something that could fit in a different package. And I'm not sure if there are any comments on that.
So one comment I have is that, you know, I think that there's the big website, which was coming out of Bernard Paulson's group. And I think that, the packages are at least are somewhat linked. I don't know if that wants to be a link that continues going forward. But if the sort of ID was, or reconciling between different IDs was handled by that website, and then you could maybe just import metabolites or reactions or models directly, that could be an interesting way of solving it in a fairly lightweight manner.
I mean, Zach, can you maybe comment a little bit on like what the long-term plans for Big are in terms of maybe becoming actually a community resource as well, and also like a reference?
Sure. Right. So so there's a lot of directions we could go with Big, and I was the one of the 2 developers on Big models, so I can answer more specifics about the database. But right now, we rely really heavily on MetaNetX, this project from Switzerland, to handle all of these external database links. So linking all of the different KEGG and MetaPsych and Big together, just in terms of identifiers. And I think an ID mapping service, so you could maybe load a file up into a Big website server and then get a new file back that had different IDs. That would be pretty straightforward. The bigger challenge is making sure that these IDs get better and the ID mappings get better over time. And we don't really have a way for people to contribute improved ID mappings. We're just relying on another database for that. So I see that as the biggest challenge. But hopefully with a lot of people looking at this stuff, we can come up with ways to crowdsource some of that to get improvements.
I mean, maybe one could actually also talk to the MetaNetX people.
Right.
But I mean, that's sort of the cobrapy scope, but maybe